questions I've chosen are a combination of multiple choice, true and false, as well as long questions. And the reason why I've chosen these questions specifically is because my sense is that they cover quite a good range of theory. So what I'm going to start with is this true and false question here. So basically, this question says the equilibrium wage for steel workers in Staldorp is currently 7 Rand per hour. A national minimum wage of 6 Rand is imposed. This results in fewer steel workers being employed than before. So for me, the real trick to answering true and false questions is to basically, at every point of the question, ask yourself, does this still make sense? And the tricky thing with true and false is what sometimes happens is one word can make the question wrong. So you have to be very, very careful answering true and false. So the theory that this question is referring to is specifically a price floor, because a national minimum wage, what they're referring to in the question, a national minimum wage is an example of a price floor. So the way that I would answer this question is either you just know your theory really well, and that means you're going to know when does a price floor have an effect and when doesn't it have an effect. The other thing that's actually quite good practice to do when you're studying for A2 and you're doing these kinds of questions is to draw as you're doing it. So that's the thing that I usually do when I am preparing for economics tests. So in this question, we have a minimum wage, demand and supply. So if the market was in equilibrium, then the market would just produce where supply and demand intersect. So that's the equilibrium wage of 7 Rand. Then there's a national minimum wage of 6 Rand. So 6 Rand is below the equilibrium. That's where the national minimum wage is set. And the whole point about a price floor is that it's impossible or illegal to charge or pay a price that is below that. So an easy way to remember this is if there's a price floor, just imagine a little person standing above it, okay, because basically it's a floor, you can't go below it. So you have this little person standing on the price floor. What that means is that all prices above that line are not illegal, and all prices below that line are illegal. So what this essentially means is that if a minimum wage of 6 Rand is put into place, it's non-binding because it lies below the equilibrium. So what that means is that essentially the market is just going to want to return to equilibrium at 7 Rand. So the second part of the statement, which says this results in fewer steel workers being employed than before, makes it false. At a minimum wage of 6 Rand, we actually see that at that very low wage, many people would be taken into employment. However, not many people would want to supply their employment at that wage. So this would be the quantity supplied, and the quantity demanded would be up here. So it is the case that because this is non-binding, the market wouldn't end up being stuck in this situation of QD being greater than QS. It would return to normal. So the next question then asks binding rent ceilings, and then essentially you have to figure out, is each of these statements then correct or incorrect? So we've just talked about binding price floors. A binding price ceiling then means that we have demand and supply. And in order for a price ceiling to be binding, that has to be set below equilibrium. So again, you can imagine this little person who's now below the ceiling. So any price that is above that line becomes illegal, and anything that is below this line is now legal. So in the case of a binding rent ceiling, we would end up having a shortage resulting. Okay, so a binding rent ceiling benefits newcomers to the residential property market most benefits current residents most necessarily result in consumer surplus being increased or necessarily result in producer surplus being increased. What we know is that prior to the price ceiling being put in place, consumer surplus is going to be everywhere that's above that equilibrium price. Now that there's a price ceiling in effect, what happens is we will have consumer surplus, some of it being lost due to deadweight loss, but then we will see that consumer surplus is going to go up. Okay, Vitomi, you have a question. So Tori asked, I thought with the price ceiling a deadweight loss arise, so then why does consumer price increase? Okay, so the nuance of this question that I'm doing here is, in this case, the way that I've drawn this picture, this price that is now the binding rent ceiling, that is now the new lower price. So that small triangle there that used to be part of consumer surplus, that is lost due to the fact that there is now a deadweight loss. But there is potentially consumer surplus to be gained because consumers are now paying a much lower price. So the whole point of a binding rent ceiling is to try and provide consumers with a lower price, because it's believed that this market is providing a good that is either essential or it's really important that it's affordable to consumers, such as housing. And that's why the price would be set quite low. And in order for it to be binding, it would have to be set below the equilibrium. So I understand the question you're asking. The important thing to know here is that binding rent ceilings do not necessarily result in consumer surplus being increased. And the reason why they don't necessarily result in consumer surplus being increased is because that loss in consumer surplus due to deadweight loss might actually have been larger than this gain in consumer surplus due to a lower price. So it really just depends on how I draw the graph. So I could have drawn this graph in a way that actually that consumer surplus that is lost due to deadweight loss, so this little part of the triangle there, I could have actually drawn this graph so that that loss in consumer surplus could have actually been larger than this gain in consumer surplus here. So that's the really important thing about these words necessarily in our answers. Because if you see the word necessarily or definitely, what that implies is that it is always the case. So it isn't true that binding rent ceilings necessarily result in consumer surplus being increased. It's also not true that binding rent ceilings necessarily result in producer surplus being increased. Because if you look at this graph here, if there's one thing we are sure about, is if a binding price ceiling is put into place, producer surplus definitely gets smaller. And the reason we know that is because some producer surplus is lost due to deadweight loss. So that's that little triangle there. So I'm going to color it in green. So that is producer surplus that is definitely lost due to deadweight loss. And then this part here that's now part of consumer surplus that's colored in red, that was previously producer surplus. So one thing we can be definitely sure about a binding rent ceiling is that it necessarily results in producer surplus being decreased, not increased. So if this had said necessarily results in producer surplus being decreased, then D would have been correct. So C is incorrect, D is incorrect. So now we have to choose between A and B. Now, if you think about rent ceilings, okay, you are currently renting an apartment and government now puts in a policy which means that your landlord may not charge you above a certain rental price. And let's say that the rental price you used to pay was the equilibrium. Now your landlord by law has to charge you the lower rent. That means you will benefit. Okay. It's not necessarily going to benefit newcomers. And the reason why it's not necessarily going to benefit newcomers is because the result of a binding rent ceiling is that it leads to an undersupply of houses. It leads to a shortage of houses. So if there's a shortage of rental houses, you're someone who already has an apartment in place. That is very different to now you, who is someone coming into the market, and you now actually end up losing the chance to find a rental apartment because now there's less available. Yes, exactly. So the answer is B, because it's necessarily going to benefit those who are currently renting, because those who are currently renting will now be paying a lower rent. But it won't necessarily benefit newcomers because newcomers aren't guaranteed to get housing because now there will be a shortage. So the answer is B. Can you please re-explain why the consumer surplus does not necessarily increase? Okay, so I'll explain that once more. So if you look at the picture that I've drawn here, okay, so the original consumer surplus is this triangle here. Okay, so it would have been everywhere that is above the equilibrium price and below the demand curve. As a result of this binding rent ceiling, what happens is that consumer surplus could increase by this red amount here. So you're going to actually gain some consumer surplus because now you're paying a lower price. However, you would have lost some consumer surplus because now there's a deadweight loss. Because instead of the amount of houses being over here, there's now only this many houses that are provided. The reason why it's not necessarily true that consumer surplus is going to increase is because the only reason why that red amount there is greater than the loss in consumer surplus due to deadweight loss is because of how I've drawn my graph. I could have drawn this graph with slightly steeper demand and a slightly flatter supply curve. And if I'd drawn my graph that way, you would actually see that any gain in consumer surplus because of a lower price could actually end up being smaller than a loss in consumer surplus due to deadweight loss. So there's two things that's happening here. Consumer surplus is increasing because prices are lower, but consumer surplus is also decreasing because quantity is now lower. And we can't say which of those is going to have a bigger effect unless I actually gave you a picture and you could see it. So without any further information in this question, you cannot necessarily know that consumer surplus is going to increase. We can, however, definitely know that producer surplus will decrease. And we can also definitely know that total surplus will decrease because total surplus would have decreased by that deadweight loss. What happened to the search costs? Okay, so search costs don't necessarily have to occur. So in this example, we actually haven't given you any information about search costs. So if we actually did give you information about search costs, so if I told you in this question that these consumers, in order to guarantee access to housing, they would have spent some of their consumer on search cost, then I can definitely say that consumer surplus would not have increased. Because if you actually spent any gain in consumer surplus on search cost, then what would end up happening is you would end up spending this area here on search cost. And that would have meant that you only end up getting a smaller amount of consumer surplus at the top. So if there is actually search activity, then definitely consumer surplus goes down. Without consumer search activity, then consumer surplus could have gone up or it could have gone down. It just depends on whether or not price going down has a greater effect on consumer surplus than quantity going down. Okay, so the answer to this question is B. Okay, it's going to benefit current residents most. Okay, then question 3 says, a country's demand and supply of labor are described by the following equations. QD equals 12 minus 0.3p, QS equals 2 plus 0.2p. The government decides to introduce a minimum wage of 15 Rand 50 per hour. This will cause a shortage of labor hours, cause a surplus of labor hours, result in a deadweight loss, or have no effect. Okay, so if we think about a minimum wage, if it is binding, leads to a surplus. Okay, so what we mean by a surplus of labor hours is there will be unemployment. Now, the reason why that isn't immediately the right answer is because we also know that minimum wages, if they are binding, lead to deadweight losses. So if this minimum wage is at all binding, it could cause both a surplus and a deadweight loss. So if you look at this question just without doing any calculations, you would maybe think maybe B is correct or maybe C is correct. The most important part of this question is trying to figure out whether or not this 15 Rand 50 is binding or not. That is the main trick. So the way that we need to find out whether or not there will actually be an effect in this market is through seeing whether this 15 Rand 50 is higher or lower than whatever the equilibrium wage rate is. So if we want to calculate the equilibrium wage rate without this price ceiling, we would set QD equal to QS. So it would be 12 minus 0.3 price equals 2 plus 0.2 price. If we then take this minus 0.3 to this side and the 2 to that side, we'll end up with 10 equals 0.5 price. We then multiply both sides by 2. So we'll see that 20 Rand is actually the price. So currently, without any government intervention, the price in this labor market is 20 Rand. So if you put in a minimum wage of 15 Rand 50, that is effectively a non-binding price ceiling. So that 15 Rand 50 would be non-binding, which means that the results of this policy would be no effect at all. So the answer would be D. Okay. So the important things with these questions is to actually determine, is this price that government is putting in actually a binding price or a non-binding price? If it's binding, then we would have to go further and see which one of A, B, or C is correct. But the fact that this price is not binding immediately makes D correct. Can you sub 15 Rand 50 into both QS and QD? Okay, so I could, yes, that would also actually, that would work. If you do that though, okay, so let's just take that approach that Emily has suggested. So if you put 15 Rand 50 into QD, you'd get a quantity of 7 hours and 7.35 hours. If you put 15 Rand 50 into QS, you would get a quantity of 5.1 hours. And that would tell you that there is then a shortage of 2.25 hours. So if you follow this approach, you would actually think that A is correct. The reason why A is not correct is because even though this would cause a shortage, that shortage would be eliminated because the wage is non-binding. So because this minimum wage is less than the equilibrium price of 20, any shortage that it creates would effectively be eliminated because the market would just want to move to equilibrium. So I totally understand why that would be the approach you would choose. The problem, though, is that it can actually lead you to a wrong answer without you thinking more clearly about the question. The point of me showing you this question is just to illustrate that sometimes the question is actually asking you to do something a little bit deeper than what it seems on the surface. Now, the reason why an answer of A would also actually be incorrect is because the theory tells us that a binding minimum wage, which is a price floor, if it was binding, it would actually lead to a surplus. So the fact that putting 15 Rand 50 into QD and QS gives you an answer of a shortage should immediately trigger something. But hang on, a minimum wage that is binding should actually create a surplus. So the fact that you're choosing an answer of a shortage, according to your theory, it couldn't possibly be correct, because minimum wages, if they're binding, should lead to surpluses because they create unemployment in the case of the labor market. So if you did get A, by implication, D is actually correct because any shortage would be eliminated. Okay, so that's just the point of trying to think about the question a little bit deeper. Okay, question 4 says, a tax of 6 Rand per unit is imposed on cigarette suppliers, increasing the price of cigarettes by 6 Rand per packet. This means that. So in this question, what we see is that there is a tax of 6 Rand, and as a result of this tax of 6 Rand, the price goes up by the full value of the tax. If you think back to your theory on tax and we think back to the graph, what we know about a tax is that you have demand and supply. So we have supply and demand. And if there is a tax, it shifts the supply curve up by the value of that tax. So this would be our supply plus tax curve. Okay. Now, if we then look at the price after the tax and before the tax, what you actually see is that this is the price after the tax. This is the price before the tax. And this here is the actual distance of the tax. So what that tells me is that normally when you have a sort of regular shaped downward sloping demand and a regular upward sloping supply, if there is a tax placed on the product, the tax is then partly shared between the buyer and the seller. So the buyer would end up paying this amount of the tax, and the seller would end up paying this amount of the tax. So the distance below the equilibrium price, this distance here, that is the amount of the tax that is paid by the producer. So the way we find that is we find the distance between the old equilibrium price and the supply curve, which actually represents the costs of the firm. So tax is usually shared. This question is telling us that the tax isn't shared. The tax is actually being fully placed on the seller because the entire difference between the original price of cigarettes and the now new price of cigarettes is the full tax of 6 Rand. If we then think about what determines the burden of tax between buyers and sellers, it's elasticity. So elasticity has to do with how responsive you are to a price change. So if buyers are completely unresponsive to a price change, which is this, perfectly inelastic. If buyers are completely unresponsive to price changes, it means that suppliers can then put the full tax onto the consumer. So the answer is C, because that is the only circumstance that would give the entire tax burden falling onto the buyer. If the demand curve is perfectly elastic, so as in D, then because consumers are very, very, very responsive to price changes. So perfectly elastic means that even if price goes up by a cent, consumers are going to stop purchasing that product. So if demand was perfectly elastic, then the opposite would be true. In that case, the price of cigarettes wouldn't change at all because suppliers would have to completely absorb the tax into their cost because they wouldn't be able to pass any of it onto consumers. So this question is essentially testing to see that you know the difference between the tax burden that is shared between buyers and sellers depending on the elasticity. So this is quite similar to one of the questions in A1 where we gave you the elasticity of supply and we gave you the elasticity of demand. And then we asked you, how is the tax divided? So the important thing to remember here is that whoever is more responsive to price will end up paying less tax. So a higher responsiveness to price will result in a larger burden of the tax falling onto the other, let me call it economic agent. So for example, if buyers are highly responsive to price, then sellers will have to pay more of the tax. If sellers are very responsive to price, then buyers will have to pay more of the tax. Okay. So the answer to 4 is C. So this falls then really nicely to question 5. So in question 5, they ask, the greater the price elasticity of what, the larger the proportion of a tax paid by who? So we can put each of these answers into this question, and using what we just saw above, we can answer this. So the greater the price elasticity of demand, the larger the proportion of a tax paid by buyers. So the greater the price elasticity of demand, that would mean buyers are very responsive to price changes. So if buyers are very responsive to price changes, they actually will not be able to have the tax put onto them because that would then result in a very dramatic drop in quantity purchased. So A is incorrect because if price elasticity of demand was great, that would mean the proportion of tax paid by buyers would be smaller. So A is incorrect. So we can eliminate A. B then says, the greater the price elasticity of supply, the larger the proportion of a tax paid by the seller. For the same reason that A is incorrect, B is incorrect. Because if suppliers have a very high elasticity, then it means they're very responsive to price changes, which means they will try to then push the tax onto buyers. Question C, answer C then says, the greater the price elasticity of demand, the larger the proportion of a tax paid by sellers. That is correct. And then D, none of the above is incorrect. Okay, so the logic of 5 comes pretty much from what is discussed above. Okay, so both of these questions try to illustrate the importance of elasticity for how the tax burden is shared. Question 6 is an example of a price ceiling, but the reason I've chosen this question is because it uses a table for the analysis. So typically the way that we ask rent ceiling and rent floors is we can either rent ceilings or price floors is we'll use equations and then you have to sub in values and then try and evaluate whether or not you're dealing with a binding or non-binding price ceiling or price floor, and then you're going to figure out, is there a shortage, is there a surplus? We could also ask it using just straight theory. The other way that we can ask it is using a table. So a table is essentially the same as a graph. Sometimes students find it a lot easier to actually replicate this table in a picture. What I am going to do is show you how to read these tables for these kinds of questions. So they tell us that the municipality is considering the imposition of a rent ceiling of 8,000 Rand per month. Help the municipality to analyze the impacts of the proposed rent ceiling. So the first part of the question then asks, with no rent ceiling, what is the rent and how many apartments are rented. So if there is no rent ceiling, that means that there is no government intervention. So the market is just allowed to operate as normal. The price mechanism just finds a way to bring buyers and sellers together, and they will settle on the same quantity demanded and the same quantity supplied at a single price. So what we need to look for is a price at which quantity demanded and quantity supplied are the same. So with no rent ceiling, the rental price is going to be 10,000 units, and 3,000 units are going to be bought and sold every month. So that answer is pretty straightforward. Part B then says, with the rent ceiling, which we were told is 8,000 Rand, so that's the rent ceiling, what will the rent be and how many apartments will be rented? Now, the reason why this part of the question is there, because I think some people could read this and be like, but they've told me the rent ceiling, so why am I getting marks for just repeating what you've told me? This is because it might be the case that the rent ceiling is non-binding. So if I told you that the rent ceiling was 12,000 Rand a month, that would make it non-binding because it's above equilibrium. So then it wouldn't be 12,000 Rand, it would actually be 10,000 Rand because the market would move back to equilibrium. In this case, it is binding because 8,000 Rand is less than 10,000 Rand. So this is kind of a free mark. Basically, we are just asking you to repeat what we've told you. So with the rent ceiling, the rent will be 8,000 Rand a month. How many apartments will be rented? So if the rent is 8,000 Rand a month, 5,000 units will be demanded, but only 1,000 units are going to be supplied. So this means that 1,000 apartments will be rented because you cannot rent what isn't available. If there are only 1,000 units available at a price of 8,000 Rand a month, then only 1,000 units will be rented. So the answer to B is 8,000 Rand and 1,000 units. Question C then says, if the rent ceiling is strictly enforced, what is the maximum price that someone is willing to pay for the last unit of housing available? So this has to do with the fact that the demand curve is the same as your willingness and ability to pay. So here we're telling you 8,000 Rand is the price that is being charged. It's a rent ceiling. However, because that 8,000 Rand is below equilibrium, it means that even though people want 5,000 units, so this would be 5,000 there, only 1,000 units are being supplied. So 1,000 units are being supplied. So only 1,000 people are getting the housing at a price of 8,000. However, if you go up to the demand curve, that then will tell you what is the maximum price the last person who rented a house was actually willing to pay for that house. In the table, the way we find that is we look at QD and we see that quantity demanded would be 1,000 at a price of 12,000 Rand. So that tells me that 12,000 Rand is the value that is placed on the 1,000th house. In other words, the person who got the last unit of housing was willing to pay a maximum of 12,000 Rand in order to access that house. So that's the answer to C, 12,000 Rand. Question D then says, how much would potential renters be willing to spend on search costs? So this relates to Dylan's question earlier. So basically, what we see from the picture here is that consumers are only having to pay 8,000 Rand per unit, but they are willing to pay 12,000 Rand for that last unit. So this tells me that that difference there between 8,000 and 12,000 is the additional consumer surplus that somebody would be willing to sacrifice on search activity in order to improve their chances of getting housing that is now in shortage. So question D asks how much would potential renters be willing to spend. So each renter would be willing to spend 4,000 Rand, the difference between 12,000 and 8,000 Rand, in order to find the last unit. Are search costs implicit costs? Search costs are not implicit costs because search, well, okay, so let me put it this way. Some search costs could be implicit and some search costs could be explicit. So an example of an explicit search cost could be the case of having to pay for an agent to help you look for housing. So you might look for a particular rental agent and then you would have to pay them. So that would be an explicit cost because you're physically having to pay them something. An implicit search cost would be time, for example. So in order for you to look for housing that is now in shortage, you would have to actively get out there and search. And instead of searching, you could have been doing something else. So there is an implicit cost attached to that because you're having to give up time in order to go and look for housing. So search costs involve implicit and explicit costs. So basically that just means they are an opportunity cost. So all costs in economics are opportunity costs because it can either be explicit or it can be implicit. Okay. So it just depends on how the search is actively being done. Okay, so I'm going to go to the next question now. So, and actually this question is with a graph, so that's great. So now I can show you how we use a graph to answer this type of theory. So we get given a picture, and the picture illustrates the market for air conditioners. Researchers indicated that air conditioners emit as much as 3,000 grams of CO2 per hour. The government decides to introduce a tax of 600 Rand per air conditioner in order to curb the emission of CO2 into the atmosphere. So this is before any tax has been applied. So without the tax, the market is going to be in equilibrium here, where demand and supply intersect. So the first question says, what will the price for buyers and the equilibrium quantity of air conditioners be after the imposition of this tax? So before the tax, everybody's paying 12,000 Rand and 80,000 units are being bought and sold. So it's always important to read the units for quantity because sometimes we use thousands, sometimes we use rands, sorry, not rands, grams, kilograms. So just always check the quantity and make sure you are aware of the measure. Okay. So if there is a tax of 600 Rand per air conditioner, that means that the supply curve is going to shift upwards vertically by the value of that tax. So whereas the supply curve would have supplied 80,000 units at 1,200 Rand per month, with the tax, it would be 1,800. We can then choose a second point. So let's go to this point here. So 40,000 units would be supplied at a price of 600 Rand. So with a tax of 600 Rand, that would make the cost plus tax 1,200. So what happens to the supply curve is it shifts up vertically by the value of that tax. The new supply plus tax curve is going to go like this. Okay, so this will be the supply and tax curve. So what that means is that with the tax of 600 Rand, the supply and tax curve is going to intersect demand at this point here. So after the tax, buyers will now pay 1,500 Rand per air conditioner, and the quantity would have fallen to 60,000. So the answer to question A is the price that buyers would pay is now 1,500 Rand, and the quantity is equal to 60,000. Okay. So that's the answer to A. B then asks, how will the tax burden be divided between the buyers and sellers? So we go back to the graph and we see that the market is now here at 1,500 and 60,000. In order to see how the tax is divided between buyers and sellers, what we notice is that before the tax, buyers pay 1,200. After the tax, they pay 1,500, which means that buyers have seen their price go up by 300 Rand. So the burden of the tax on buyers is 300 Rand per air conditioner. The difference then is the tax that has to be paid by suppliers of air conditioners. So suppliers used to get 1,200 Rand per air conditioner. After the tax, they are getting 1,500 Rand from consumers, but 600 Rand of that 1,500 Rand is a tax that needs to be paid to government. So if we go from this point here all the way down to the supply curve, and we see that suppliers actually now are only receiving 900 Rand, it means that 300 Rand of the tax is falling on. And the other way that you can see that sellers are paying this blue portion here is by taking the difference between what sellers used to receive, which was 1,200, and what they now effectively receive, which is 900. So even though somebody who's buying an air conditioner goes into a shop and they pay 1,500 Rand, that isn't the money that sellers keep at the end of the day, because of that 1,500 Rand they receive, they're going to have to pay 600 Rand over to government. So the price that sellers actually receive is 900 Rand. So the difference between what they used to receive and what they now receive is 300 Rand. So this means that the tax is divided equally between buyers and sellers. They each pay 300 Rand. And the reason why the answer to this question is an equal division of tax is because if we look at the demand and supply curve, the demand and supply curve appear to have the same relative elasticity. So demand and supply are relatively equally elastic. And because buyers and sellers are equally responsive to prices or equally unresponsive to prices, it means that the tax is going to be shared equally between them. If the demand curve had been steeper, that would have put more of the tax on buyers. If the supply curve had been steeper, that would have put more of the tax on sellers. So in this case, elasticity is relatively the same, and that's why they end up being equally shared between buyers and sellers. The last part of the question, question C, then asks, how much tax revenue is generated per month? Show all calculations. So the tax revenue is calculated as the tax per unit multiplied by the quantity that is sold in the market. So the tax per unit we know is 600 Rand, and after the tax is put in place, quantity is 60,000. So the answer will be 36,000,000. So it's going to be 36 million Rand. Okay. So this is where it's important to note the units of measurement, because you might not have had that 1,000 in there, and then the answer you would have gotten is 36,000 Rand instead of 36 million. So units of measurement is always important to read off of a question, especially questions that involve calculations, because You don't want to lose marks unnecessarily through misreading a graph. I think now we're going to go to chapter 8 and 9. Yes. Okay. So I've chosen quite a few questions for chapter 8 and 9 just to make sure that we have an understanding of a good understanding of the budget line and the indifference curves and where consumer equilibrium is. So I'm trying to go through it in order. So we're going to start with the budget line and then move up to the indifference curves and then move up to consumer equilibrium. So the first thing we have is Sarah has 100 Rand to spend on carrots that cost 20 Rand per kilogram and on mushrooms that cost 50 Rand per kilogram. If we draw her budget line, okay, so that's misspelled, with carrots on the horizontal axis, her budget line's equation is given by this. So the way to answer this question is to simply use the values we've given you and see whether or not you come out at this budget line. So there are a few ways to answer this question. The one way that you can answer this question is if you know the form of the budget line, then you would know that quantity of whatever is on the y-axis, in this case mushrooms, because carrots are on the horizontal axis, is equal to income divided by the price of whatever is on the y-axis minus the price of whatever is on the x-axis divided by the price of whatever is on the y-axis times the quantity of the good on the x-axis. So this is the general form of the budget line. So if we take those numbers and we sub it in, we get QY is equal to 100 divided by 50 minus 20 over 50 times the quantity of X. And if I simplify that, 100 divided by 50 gives me 2. And 20 divided by 50 gives me 2 over 5. So using knowledge of the general form of the budget line gets you to that answer. So the answer to this question is true. It's A. So that's if you remember that equation off by heart. The other way you can answer this question without having to know this equation off by heart is you can draw it. So the budget line is drawn with the quantity of y on the y-axis, and we have the quantity of x on the x-axis. And then the budget line we know is going to be some straight line. And the important part is getting the intercept on the y-axis and the intercept on the x-axis. So how do we get this intercept? So this point here tells us how many mushrooms she purchases if she had to spend all her money on mushrooms and consume absolutely no carrots. So if she has 100 Rand in total and mushrooms cost her 50 Rand per kilogram, that means she could buy 2 kilograms of mushrooms. So the y-intercept is 2. So things are looking good so far. We get the intercept of 2. If she spent all her 100 Rand on carrots, then she would be able to buy 100 divided by 20 Rand per kilogram of carrots. So this value here would be 5, which means her budget line would be some straight line between 2 and 5. And if you wanted to calculate the slope of this line, you would take rise over run. Minus 2, because you'd go from 2 to 0. So it would be minus 2 over 5, and that would give you minus 2 over 5. So the answer is true, whether you use knowledge of this formula or whether you plot it using a picture like this. Okay, so that's how we get true for question 1. Question 2 then says, if a consumer's expenditure is equal to his available budget and marginal utility of X equals 2 times marginal utility of Y, then the consumer should buy more of good X and less of good Y if and only if. And then we have a number of statements here. what these statements ask you is whether or not the price of X must be less than or more than some function of the price of Y. So this is kind of a tricky question. So I'm going to show you step by step how you would go about answering a question like this. And what you need to do is use your theory of consumer equilibrium. So what we know about consumer equilibrium is that the marginal utility of X divided by the price of X should be equal to the marginal utility of Y divided by the price of Y. Okay, so this we know. The second part of this statement here has told us that the consumer should buy more of good X and less of good Y if. So if these things are equal, that would mean you're at your highest utility. So you wouldn't choose to change anything about how much X or Y you consume. If the consumer wanted to buy more of good X and less of good Y, that would imply that this relationship should look like this, okay? If the marginal utility of X per rand was greater than the marginal utility of Y per rand, that would tell us that the consumer needs to buy more X and less Y. The reason why that tells me that he wants more X and less Y is because every unit of X that he purchases is going to offer him more utility per rand than every unit of Y he purchases. So an example, a really, really silly example, but an example that works quite well to explain this is, let's say you could choose between a slab of chocolate that's 20 rand, and that slab of chocolate is going to give you marginal utility of 50, or you could purchase, so let's say this is that Cadbury, the bubbles, the bubbly one, okay? Or you could buy a slab of Lindt chocolate for 40 rand, so twice as much, and the Lindt chocolate is going to give you a marginal utility of 80. What this tells me is that either you can buy the Cadbury's or the Lindt. If we just compare the prices, the Lindt is more expensive than the Cadbury. So if all we were comparing is prices, we would buy the Cadbury because it's cheaper. But if we compare the utilities, you would go for the Lindt because the Lindt gives you more utility than the Cadbury's does. So you have these two conflicting outcomes depending on whether you're using price to compare or utility to compare. And that is why we use both. And that's why we have to use marginal utility divided by rand in order to decide whether or not a consumer should buy more of one thing or more of another. So if I take this marginal utility of the Cadbury chocolate and divide it by price, I will get 50 divided by 20, so I'll get 2.5. If I take the Lindt chocolate and do the same thing, take 80 divided by 40, I get 2. So what this tells me is that Lindt, for the Lindt chocolate, I'm only getting 2 units of utility per rand spent. But with the Cadbury's chocolate, I'm getting 2.5 units of utility per rand spent. So because this is bigger, it means I would go for the Cadbury's chocolate. So this is the same logic I'm using here. If the marginal utility of X per rand is greater than the marginal utility of Y per rand, that means I would buy more of good X and less of good Y. So we have this equation to begin with. I then substitute in this knowledge here. So MUX equals 2MUY. So 2MUY divided by the price of X is greater than the marginal utility of Y divided by the price of Y. So all I've done is made a substitution. I then can eliminate the marginal utility of Y from either side of this equality. So what I get is 2 over price X is greater than price Y. Sorry, 1 over price Y. Okay. If I then rearrange this equality here, 2 over price x is greater than 1 over price y, I will get 2 times price y is greater than price x. And that's how I get to the answer of C. Because C states the price of x is less than double the price of y. And that's what I have here. 2 times the price of y is greater than price x, which is the same as saying price x is less than 2 times the price of y. So now that we have that, we can go on to the next question. So the next question says, Melo Kuchle maximizes his utility by spending his entire income of 110 Rand on Kit Kats and iced tea. The table below shows his marginal utility from each product. The price of a Kit Kat is 15 Rand and he buys 4 Kit Kats. He currently consumes 5 iced teas. So we have quite a bit of information here. We know that his budget is 110 Rand. So whatever he buys has to add up to 110 Rand. So that's the one condition of consumer equilibrium. The one condition is spend all income. The other condition is make those marginal utilities per Rand equal. Okay. So they've given us a clue and said he currently consumes 5 iced teas. So we know that he's currently here. If he's currently consuming 5 iced teas, and iced teas, we don't yet know what the price is. So they ask us, calculate the price of an iced tea if Melo Kuchle spends his entire budget. Okay, so he buys 5 iced teas and he buys 4 Kit Kats. And a Kit Kat is 15 Rand. So that tells me that he is currently spending 60 Rand on Kit Kats, because 4 times 15 Rand is going to be 60 Rand. So this is how much he's currently spending on Kit Kats. If he has a total of 110 Rand to spend, then it means he has 50 Rand left over for iced tea. So if he has 50 Rand left over to spend on iced tea, and he's spending this money on 5 iced teas, it means that each iced tea is 10 Rand. So the answer to question A is 10 Rand. And the reason why this is worth 2 marks is because there are a few steps involved in order to get to that answer. Okay, so the important thing is to know that he has to spend all his money. Question B then asks, what is Melo Kuchle's total utility at his current consumption? So this question caused a little bit of issues in the past, which is why I chose it for the revision, because essentially total utility is going to be all the utility he's gotten once he's arrived at this point of 4 Kit Kats. So to arrive at 4 Kit Kats, he had to have eaten 1 Kit Kat. He would have had to eat the 2nd Kit Kat and the 3rd Kit Kat and then the 4th Kit Kat. That means his total utility from Kit Kats is all those numbers added together. So his total utility from Kit Kats is currently 75, 101, 122. So he's getting 122 units of utility from Kit Kats. To get to 5 iced teas, the same applies. He would have had to drink the first one, the second one, the third one, the fourth one, the fifth one. So his total utility from iced tea are all those values added up together. So total utility is basically all those marginal utilities added up. So he's getting 122 units of utility from Kit Kats. So his total utility is 122 for Kit Kats. For iced tea, he's getting 94, 130, 170. So his total utility from all consumption is 292 units of utility. Okay, so the trick to this is knowing that he had to have consumed each of these Kit Kats and each of these iced teas, giving him all of these marginal utilities. So the total utility is 292. So this is a little bit different from other questions where we give you total utility and then you have to work out marginal utility as the change in that total utility. So this is just that in reverse. Question C then says, why would the decision to consume 2 additional Kit Kats take Melokuchle out of consumer equilibrium? Explain your answer fully. So this is a 4-mark question. And the minute you see 4 marks, that tells you there's quite a bit that you need to write down, or at least quite a bit of working out that you need to show us. So at the moment, he's consuming 4 Kit Kats. The 4th Kit Kat gave him utility of 21. So just that last Kit Kat consumed. He's drinking 5 iced teas, and the last iced tea he drank gave him a marginal utility of 14. So currently, what we have is we have marginal utility of Kit Kats divided by the price of Kit Kats is equal to 21, and Kit Kats were 15 Rand. So currently, he's getting marginal utility per Rand of 1.4. With regards to iced tea, marginal utility of tea divided by the price of tea is currently 14 divided by 10, so also 1.4. So what we've actually shown is that he's currently in consumer equilibrium. If he changes his consumption to 2 extra Kit Kats, it means that his marginal utility of Kit Kats per price of Kit Kats is now going to be 16, because 2 additional Kit Kats will mean he's going to consume 6. So now his marginal utility from the last Kit Kat is 16. We divide that by the price of 15 Rand, and we get an answer of 1.07. Okay. Now, he can't just consume 2 more Kit Kats and still continue to consume 5 iced teas, right? Because if he's consuming 6 Kit Kats, it actually means he's spending 90 Rand on Kit Kats, because he's spending 6 times 15, which means if he consumes 6 Kit Kats, he's going to have to reduce his iced tea to 2. If you increase Kit Kat consumption by 2, it's going to take you to 6 Kit Kats. That means your marginal utility of the last Kit Kat divided by what you spent on that Kit Kat is going to be 1.07. The important thing now to note is that in order to consume 6 Kit Kats, you're going to have to give up some iced tea, because increasing your consumption of Kit Kats from 4 to 6 comes at a cost, because you only have 110 Rand to spend. So moving from 4 to 6 takes your spending on Kit Kats from 60 Rand to 90 Rand, okay? Because 6 times 15 Rand is going to be 90, which leaves you only 20 Rand to spend on iced tea. So if you're consuming 6 Kit Kats, you only have enough money left over to buy 2 iced teas. So that means that the marginal utility of tea per Rand spent on iced tea will now be 44, which is the marginal utility of the second iced tea, divided by the price of iced tea, which is 10 Rand, which is going to be 4.4. So the result of this change in consumption takes Melokuchle to a point where the marginal utility per Rand of tea far outweighs the marginal utility per Rand of Kit Kats. So although he started off in equilibrium, through making this decision to increase his consumption of Kit Kats, has taken him out of equilibrium and to a point where he should actually be consuming more iced tea and less Kit Kats. Okay, so the important part to this question is remembering that if he increases his Kit Kat consumption by 2, from 4 to 6, he has to sacrifice some iced tea. So we wouldn't be comparing this 1.07 to that 1.4 there, because that would be unaffordable. We have to find his new marginal utility of iced tea per rand spent on iced tea, and that will then prove that even though he's spending all his money here, he's not spending it efficiently. He could have more utility if he went back to this consumption there. So I'm going to answer each question at a time. So Alexa, you ask, if we were to answer that question with showing the calculations and then explaining them, would that be okay? That would be perfect. So the question very specifically says, explain your answer fully. Now, explaining your answer fully could mean trying to give us as much information as you think is required in order for us to understand, how you got your answer. And in this example, it would mean a combination of calculations and explaining your calculations. Okay. Megan, you ask, how did you know it went to 2 iced teas? I'm not sure how you immediately knew it was 2. Okay, so the reason I knew that his iced tea consumption would go to 2 is because if he began consuming 4 Kit Kats and 5 iced teas, that meant he spent all his money. If he now decides to increase his Kit Kat consumption by 2, he's going to have to spend an additional 30 Rand on Kit Kats that he wasn't spending before. And if you're spending 30 Rand more on Kit Kats, that means 30 Rand less to spend on iced tea. And if iced tea is 10 Rand each, and he used to buy 5, but now he has to spend 30 Rand less on iced tea, then he's buying 3 fewer iced teas. So the decision to increase Kit Kat consumption by 2 comes at the cost of decreasing his iced tea consumption by 3. So that's how I got to that answer there. Mo, you ask, how would you answer this question descriptively in a test? So if you had to answer this question descriptively, I think you would have to include those marginal utility per rand calculations. Using just words will be very tricky. So what I'll do is I'll quickly add some words to this just to show you how it would be both a combination of words and these calculations. So how you start off is you say, okay, currently he consumes 4 Kit Kats and 5 iced teas, spending all his income of 110 Rand. This combination of Kit Kats and iced tea maximizes his total utility because the marginal utility per rands are equal. And then you show that. So you prove that. The next part of the question descriptively is, if he increases his Kit Kat consumption to 6, he has to spend 30 Rand more on Kit Kats because it's 2 times 15 Rand. This means he has to consume 3 less iced teas in order to stay within his budget of 110 Rand. At this combination of Kit Kats and iced tea, he is no longer in consumer equilibrium because the marginal utility of Kit Kats per Rand spent on Kit Kats is less than the marginal utility of iced tea per Rand spent on iced tea. So a combination of these calculations and this explanation would definitely guarantee you the full 4 marks for that question. This is quite a nice past paper question because it's asking theory that is actually very similar to the question that was in A1, but it's a little bit deeper And it's testing some new things that maybe hasn't been asked in exactly the same way in other papers. And it's always good to get a sense of all the different angles of a question and a theory and how they all fit together. So I really like this question. Okay, the next few questions are in indifference curves. Which of the following is not a property of indifference curves of ordinary goods? So ordinary goods is a very particular description. Normal goods and inferior goods can be ordinary or substitutes or complements. Okay, so ordinary isn't the same as normal. Ordinary has to do with the shape of an indifference curve. So what we mean by ordinary is that it illustrates ordinary preference behavior. And ordinary preference behavior means that indifference curves are shaped like that. Okay, so an ordinary good has a convex shaped indifference curve. That's very different to perfect substitutes, which have straight line indifference curves, and then perfect complements, which have these L-shaped indifference curves. Okay, so this is a perfect substitute, perfect complement, ordinary good. So in terms of the answers they give, ordinary goods are not straight lines, okay? Because this would describe a perfect substitute. So that makes A correct because the question is asking which is not a property. Then just to check that the other three are correct, indifference curves slope downwards. Yes, ordinary goods do have downward sloping indifference curves. Ordinary goods have indifference curves that never cross. Now I'm going to get to that in the next question here. And that is most definitely a property of ordinary goods indifference curves. And then D, higher indifference curves are preferred to lower curves. That is most definitely true. The higher the indifference curve, the greater the utility that the bundles of goods on those curves represent. So if I was at a point here on this curve, I would be getting less utility here than I would be getting if I was at a bundle on this indifference curve. If I was comparing that indifference curve bundle to another bundle on that same indifference curve, so I'll call it A and B, what that means is that A and B give exactly the same utility. Okay, if this is C, C is preferred to both A and B because it is on a higher indifference curve. So the answer to question 4 is A. Okay, because this describes perfect substitutes. The reason why indifference curves can never cross each other is because if we take the idea that higher indifference curves represent more utility, and we assume two indifference curves that cross, okay? So here's one indifference curve, I'll call it I1, and here's another indifference curve I2. Let's say that this is bundle A on indifference curve 2. This is bundle B on indifference curve 1. And then bundle C sits exactly where those two curves intersect. A and C are on the same indifference curve. What that means is that in the eyes of the consumer, A and C are equal. So I get exactly the same utility as I get from C. So the consumer should be completely indifferent between A and C. If I then look at I1, C and B are both on I1. So in the eyes of the consumer, B is the same as C. Let's say there's a bundle D up here. So D is also an I1. So D, C, and B, the consumer likes them equally. Okay. I don't care if you give me B, C, or D. Those three make me equally happy. But if you had to compare A and D, D clearly should be preferred to A, because D is getting you more consumption of both things. And what we know about consumers is that the more they are consuming, the happier they are. That's the sort of basic oversimplified logic. So D should be preferred to A. But if A is the same as C and C is the same as D, then D and A should be the same. So this basically violates logic. It shouldn't be logically possible that D is preferred to A, but also equal to A. And that is the reason why indifference curves cannot cross. They cannot cross because it would imply that consumers are indifferent between two bundles of goods where one bundle contains more of both products than the other bundle. So this answer B here refers to that comparison of A and D. Okay, so indifference curves cannot cross because ultimately it would mean that something that gives me less of both things is just as preferred to another combination that gives me more of both. And that can't possibly be true. Okay, so the last question we're going to do is this question 6. So question 6 says, a consumer consumes good X measured on the horizontal axis and good Y measured on the vertical axis. What is the significance of the fact that the consumer's budget line has a negative slope? So this question is one of those questions, I think, where students can read the answer, and then once they start reading the answers, you start to trick your mind a bit because many of the answers seem to be correct. Now, there's very clearly two wrong answers here. D is incorrect because marginal cost is not linked to consumption. Marginal cost is linked to production. Marginal cost is a topic that refers to suppliers, whereas marginal benefit is what refers to consumption. So it isn't marginal cost that increases as the consumer consumes more of X. It is actually marginal utility that decreases as the consumer consumes more of X. So as we consume more of something, the marginal utility we get from that thing becomes smaller and smaller. So D is very wrong. C is also wrong. The budget line has to do with what is actually possible for a consumer. So a consumer has a certain income. They're consuming two different products, and those two products have different prices. So the budget line reflects what is possible for the consumer. So the only option we have left is A and B. Now, the answer to this question is B, and I'm going to explain why B is correct and A is incorrect. So if you read A, it says the consumer is willing to give up fewer units of Y to get one more unit of X as the consumer consumes more of X. Whereas B says the only way that the consumer can get more units of X is to give up some units of Y. So the difference between these two answers has to do with willingness and the only way, which says something about having to. So it's that distinction between having to do something and being willing to do something. So the budget line shows us how consumers have to trade off two goods. And then given those prices and given your consumption, you then have to spend your money in a particular way. Indifference curves have to do with willingness to give up. So indifference curves illustrate how a consumer is willing to trade off one good against another.